All right, so to wrap up the lab that we did, we want to talk about the graphs of absolute value equations, how to write the equation from a graph, and it's going to be pretty simple. We've established a pattern that we're going to use in graphing these guys. And the pattern was meant to be this. So in an absolute value function, you're going to find numbers in different positions of this general form of the function. You're going to find a number here, here, and here, and each of those numbers are going to give us different pieces of information. A is going to tell us whether the V, remember that these guys make V's, whether the V opens up or opens down, and it will tell us the slope of the right side of the graph, and the slope will tell us how thin or wide this V opens up. Okay? But it's the slope of the right side of the graph. H, if you remember from the lab, H is what tells us how far the V shifted left or right. Okay? So the number inside the absolute value bars are going to tell us which way that the graph shifts left or right. The other thing we noticed was that it went in the opposite direction that we thought it would go. So if we were subtracting a number inside of there, instead of moving to the left, it actually shifted to the right. And when we added a number in there, instead of moving to the right, it actually shifted to the left. So we're going to use the opposite sign. Now, left and right is the direction of the x-axis. So when we start talking about the vertex, where the vertex is, h is going to be the x-coordinate for our vertex point. Okay, so we want to keep that in mind. And then we've got, so I need to move that down here. Okay, and then we've got k. Okay, k tells us, told us how far the V shifted up or down. And the nice thing about k was when the V shifted up or shifted down, this k, it went the direction that it looked like it should. So in other words, if we added k, then the V shifted up, and if we subtracted k, then the V shifted down. So it moved the way that we thought that it should. So we're not going to change the sign of that guy. So how do we put that together? All right, well, this is going to give us our slope, how thin or wide it is. It's going to tell us if it's going to open up or down. These two guys are going to come together to form the point for where that corner is, that vertex. And what we're going to do is we're going to create the coordinates. And since h shifted the V left or right, that's going to be our x-coordinate, and we're going to use the opposite of h. And since k shifted the V up and down, that's the direction of the y-axis, so that's going to be our y-coordinate for our V. And we're going to use the same k. So I'm going to keep saying opposite h, same k for our vertex. Okay? All right, let's try this out. Before we start graphing, let's just try to pull out the information. Okay? So for this first guy, y equals 2, absolute value of x minus 3 minus 8. Okay? Well, from this guy right here, it's positive. So since it's positive, this v is going to open up. And that tells us that the slope of the right-hand side is going to be 2 over 1. So we'd go up 2 over 1 from the vertex. Now, the vertex, speaking of which, is going to be a point that is going to be located at 3, positive 3, comma negative 8. We use opposite h and same k. So we would go put a point at 3, comma negative 8. Okay. Same thing for this next guy. Since this a is negative, then that means that the v is going to open down. The slope of the right-hand side is negative 1 over 1, which makes sense for the v to open down, because from the vertex we're going to go down 1, right 1 for our slope, and that's going to open down. Our vertex, again, is going to come from opposite h, same k. Opposite h, well, there's not a number in there. From the general form, we're supposed to be subtracting a number. So what number do we subtract from stuff and not change anything? Well, that number is 0. So if you don't see a number inside of here, then that's going to tell us that that coordinate is 0. So opposite h, same k, makes the vertex 0, 9. Okay? Make sense? try these two. Come up with the direction that it opens up, what the slope is, and then the vertex. Okay, stop the video, try them, and then start it up again and check your answers. Okay, so what did you come up with? This is going to open down. The slope of the right-hand side is going to be -1/1, and the vertex is going to be placed at -7, 0. Opposite h. Opposite h. That's going to be the easiest place for you to make a mistake, is to not change that sign. Opposite h. Same k, and there's nothing out here, so that means that that k's got to be 0. Now, there's nothing out in front of these absolute value bars either, okay? But the difference is we're supposed to be adding a k out here. And again, if you add 0, you don't change anything, so that's why k gets to be 0. Out front of the absolute value bars, we're multiplying. And you multiply by 1 and not change anything. So if you don't see an a out here, that a has got to be 1. So there's the difference. Okay. Now, what did you get for this guy? This guy, the number 4, is going to open up. The slope is going to be 3, and the vertex is going to be at -11, 9. Opposite h, same k. Okay. All right. We also want to work backwards. We want to take the information and be able to write the equation. Okay, all this stuff's going to help us graph in just a minute. So, you kind of start with a template when you want to write the equation. So y equals, that template should look like this every time. Okay, now we just start plugging in the numbers. This is our a. Remember, the slope goes out front, so this is going to be a 1. And then our vertex came from opposite h, same k. So I'm going to put a -3 inside of here and a -4 out here. Okay? And that's it. That's your equation. Now, if you want to leave this 1 in, you can. Most textbooks won't, so just write it like that. Okay? Same thing down here. Start with your template. Y equals absolute value bars with an x here. And then we're going to plug in numbers. Here's your a. So this becomes -1. Then we go opposite h, same k, so we're going to go +7, +1. Okay? And again, if you don't want to write this 1, you don't have to. Most textbooks won't. So this is how you'll see the answers. Okay? All right, you got 2 for you to try now. Try to write the equation, stop the video, and you can start it back up and check your answers. Okay, how'd you do? You should have come up with y equals 5, absolute value of x plus 8 plus 12. Opposite h. And then down here for number 8, you should come up with y equals -6, absolute value of x plus 5 plus 10. Again, opposite h. See, I just made that mistake. Opposite h. Okay? All right. How do we use this information to graph? Okay, well, let's pull the information out of an equation first, and then we'll graph it. So here, the a is 1, so it's going to open up. The slope on the right-hand side is going to be 1, and the vertex is going to be at 0, 6. Hopefully you can do that at this point. So what do we start? We start the vertex. So we go 0, 6, which is right here. Then we want to go up 1, right 1, up 1, right 1. Now, since we know this is going to be a V, we're going to go we're going to sort of mirror this on the other side of the vertex. And that'll tell us how to draw our V. And it's there. Okay? Now, what we haven't been talking up until now is domain and range, and we need to. Okay? So, you have to think back. Domain and range. Domain were the inputs of our function way back when, and the range were the outputs of our function. The domain were, when we made those XY tables, the domain were the X values that we were plugging into a function. The range were those Y values that we were figuring out what was coming out of those functions. So x is our domain, y is our range. That's what the bottom line is. And so instead of having all of the values of x and all of the values of y that fit into this function, we only have this graph. We can use the graph by thinking about if this graph is going to touch, one way to look at it is this graph going to touch the grid lines that correspond to all the different x numbers? In other words, is this graph going to touch the grid line for x being 1? Yes. What about for x being 2? Yeah, this graph touches that grid line. The graph touches the grid line for x being 3 and 4 and 5. And as a matter of fact, since this is an arrow going out to the right, it's going to touch all x values to the right. So it's going to go all the way out to positive infinity. And look on the other side. It's the same thing. It hits the grid line for x being -1 and -2 and -3 and -4. And so it's going to extend all the way out to negative infinity on the left-hand side. So our domain, we don't want to write every possible value of the domain. So we can use what's called interval notation. Interval notation says that you can create a pair of parentheses. It's going to make it look like a little bit like a point, like the coordinates of a point. Well, since this graph is going to touch all x values to negative infinity and all x values to positive infinity, then that tells us that our domain stretches from negative infinity to positive infinity. And that's how we would write that. Now, you could also say that the domain is all real numbers. I like interval notation better because it's shorter, easier to write. Okay? Now, same idea for the range values. Which grid lines corresponding to the values of y is this v going to hit? So, for example, is the v going to hit the grid line that corresponds to y being -9? No, it's not. The v starts at 6 and goes up, so it's not going to touch down here, or here, or here, or here, or here. It doesn't touch a grid line corresponding to a y value until it gets to 6. So our range starts at 6 and includes 6, so we're going to put a bracket around 6. But then it starts to extend out and up to where it hits all other y grid lines going to positive infinity. So our range is going to end out at positive infinity. And so that's how you would write the range. Okay, now, little tip for you. The domain for at least absolute value functions is always going to be negative infinity to positive infinity. It's always going to be that. The range is the one that's going to change, and you have to pay a little bit of attention to. Now, to help you with that, if it opens up, then the left side of our range is going to be the same thing as our k. If it opens down, then the right side of our range is going to be the same thing as k. You're going to see that as we keep writing these. Okay? All right, let's try another one together before I turn you loose. Graph it first. All right, so the a is -1/1, so it's going to open down. The vertex is going to be at opposite h, same k, so 3, 0. So we go to 3, 0. The slope is -1/1. So we do that a couple of times and then mirror it on the other side. And there's your v. Now, domain and range. Well, the domain is going to stretch from negative infinity to positive infinity. It will every time. The range. Now let's see how the v opens down. It's going to hit all of these values going down to negative infinity. So we start down here at negative infinity. Okay? And then we work our way up to see that the v keeps hitting until we get to 0 on the y-axis. And so our range goes from negative infinity to 0. Okay? So that's how we're going to write our range. Now, you also need to keep in mind that we read left to right. Number lines go from negative to positive, and so when you write your domain and range, you want to start with the negative side first and end on the positive side. Now, obviously, the range is going to begin and end at different places, and it's going to change a little bit, so you have to really think about the range. Oh, by the way, the right side of this range was just the k value, and it's because the v opened down. So these patterns you need to sort of pay attention to. All right? One more time. A is 1. Vertex is at negative 4, comma, negative 3. So negative 4, negative 3 is here. And then we need to go up 1, right 1, up 1, right 1, and mirror that. And then we draw our V. Domain and range. Again, because the V goes out, it's going to hit all real numbers on the x line. So it's negative infinity to positive infinity. Now, down here, it doesn't touch any values down here. So we don't start our range until we get to there, which is negative 3. And then it stretches all the way out to positive infinity. So there you go. Okay? You try on your own. Okay, we've got plenty of these to practice. Try this guy, stop the video, and then start it back up to see how you did. Okay, should have gotten this. Did you? I hope you did. Okay, got another one. Let's try this guy. Okay, did you get this? Hopefully. Okay, if you're not, make sure you come see me and we'll work through it, no problem. Okay? Got another one. Stop the video, give it a try, and see what you come up with. Did you get this? That's what you should have come up with. All right? All right. Now, we want to work our way backwards now. So we want to be able to go from the graph to the equation. And it was a lot easier if we knew what the vertex and the slope was. It was given to us before and we wrote the equation. That was pretty easy. So let's go through and do that now. Where's the vertex and what's the slope? Well, the vertex is sitting here. So the coordinates of the vertex are negative 5, comma 6. And the slope on the right-hand side is down 1, right 1, 2, 3 to get to there. So down 1, right 3 means the slope is negative 1/3. So now we use that to write our equation, our template, remember? All right. That means we stick a negative 1/3 out front. Opposite h makes this plus 5 and then plus 6. Okay? That should be a plus there. Okay? Now you try. Pull out the vertex, the slope, on the right-hand side only. Don't worry about the left-hand side, just the right-hand side. Plug it into the equation, see what you come up with. Stop the video and then check your answer when you're done. Okay. Did you come up with y equals 3, absolute value of x, and then minus 7 on the outside, right? So the vertex is at 0, negative 7 right here. Kind of hard to see. And then the next street corner that the graph goes through is where you wanted to walk your slope to, right? The next street corner was right here, so we had to go up 1, 2, 3, and right 1, and so the slope on the right-hand side was 3 over 1. Okay? All right. One more. Vertex, slope. So go from the corner and then down the right-hand side, get to the next street corner the best you can, and then write the equation. Okay, did you get this? If not, make sure you come find me during STAR or after school and we'll talk about it. All right? That's it. You got your homework out in Canvas. Make sure you have that done next class period.